This video is on electron configurations. If you did not fill in the table in the previous video, you need to do so now. You should, in your notes, have a periodic table that looks empty. Your job is to color the different sections that I have here and make sure you label the different blocks and also down the side as well. So pause the video, take a second and do that if you have not. If you have, let's move on. So this video is on electron configurations, and as soon as you pick up on that pattern that we're going to be talking about, it'll be extremely easy. So this is the pattern. Every configuration is going to end up with a big number, small letter, and an exponent, and it just keeps on going. 1s2, 2s2, 2p6, and so forth. You will follow this pattern that's on this page over and over again to a certain point. So the thing that you've got to figure out is where the stopping point is. Now, you do not have to memorize this. The periodic table is going to be the tool for you in order to solve these problems. So a couple things. The period number, which is the row number, so make sure that you know period number is the same thing as your row number, tells you the number of energy levels, or it tells you the energy level that electron is on. Now for your D's and your F's, if you remember in this picture that you colored, it says here for the D block you do n-1, for F block you do n-2. So when talking about n, it's talking about your row number. So you're going to end up subtracting for those two. The AB group number is the total number of valence electrons. So on your reference table, these have A's written on top of them. And all of these have B's written on top. And the Roman numeral that is there tells you the number of valence electrons. So for example, this is column 13, but it says A like that. That means there are 3 valence electrons. Okay, so the group number, which is the column that's beside your A and B, is the total number of valence electrons. Now, valence electrons means your outer electrons, the ones that are on the outermost energy level. The column within the sublevel block is the number of electrons in that sublevel. So the sublevel block is where you have the different colors here. So this is sublevel S, D, P, and F. So this is the first column in the S block. So this means, looking at this definition, that there is 1 electron per that sublevel. If you have over here, if you're in the second column, that means there's 2. Sorry, I'm not even in the picture. If you're over here, that means there are 2 electrons per that sublevel. Okay? Alright, so an example of what I was just talking about. Hydrogen, which is right here on the periodic table. This is hydrogen. So if we look at this first number that's out in front, the big number, this is your energy level. Okay, so the big number out in front tells you the energy level. Now you're able to use your periodic table as a tool here, so you can tell what energy level you are on based on where you're at in the periodic table. So hydrogen's in that first row, so therefore it's on energy level 1. We know that it's 1s because it's in the S sublevel. So you remember in the drawing that you did, these are your S's. Then you get the small exponent number. Remember, this is the number of electrons in the sublevel. Okay? So this means, since it's in the first column of the S block, that means there's only 1 electron in that sublevel. Okay? So, let's try a couple of examples where we're actually doing the whole entire electron configuration. Now, the first one, you may get a little bit like, what's going on here? But hopefully by the time I do the second one, it'll click a little bit better. And then we're going to also do more practice in the classroom as well. So if you take the drawing that we did and take all the elements out of it, and simply know that this is row 1, 2, and so forth. These are the S's, the D's, and the P's. This is what it would look like. So we're sort of ignoring all the different elements that are there. But every element that's on here is in energy level 1 and S sublevel. As you go across, you go down, you get energy level 2, S block, P block, and so forth. So what we're going to do is we're going to do the electron configuration of the element that is right here. So to do this, you're always going to start at the top and work your way down to your element. So remember, as you go from one element to another, based on how the periodic table is set up, you're adding one electron. So you're going to build on to that electron configuration as you go across the periodic table. So we're always going to start off with 1s. Always. So example 1 I'm doing down here. We're going to start off with 1s. Now, is our element in the 1s's at all? When I'm talking about that, I'm talking about on the periodic table. So our element is not here. That means its 1s orbital is completely full. So in order for the 1s's to be completely full, that means there are 2 electrons in it. Because remember, the S sublevel can hold 2 electrons. Now also, if you can't remember that it can hold 2, you simply count the blocks. So 1, 2. So the S's are full. You move across, just like reading, you then go to the next line. So the next thing that we come to are the 2 S's. So you're going to write 2s. Again, ask yourself, is your element either one of those 2? No. So that means this is going to be 2s, 2. Move across. You now are hit the 2 p's. So you're going to put 2p. Is your element within that row? Yes, because it's right there. So you simply count to that row, or sorry, to that column. So that means it's 1. So this means 2p1. So the overall configuration of this element is 1s2, 2s2, 2p1. Now, if you look at your actual periodic table, you should be able to tell that this is boron. Okay? Now, you can double check yourself with the electron configuration, because if you go and add up all these exponents here, so 2 plus 1, that should equal your atomic number, which in this case, 2 plus 2 plus 1 is 5, which is the atomic number of boron. So this is simply showing you where all the electrons are in a boron atom. Okay, so let's try example 2. Example 2, we go a little bit further here, so we're going to go here. Okay, so we're going to start at the top, work our way down. So again, 1s. Our element is not there, so that means the 1s's are completely full, so that is 2. Okay, now you drop down, we hit the 2s's. Element's not there, so the 2s's are completely full. So 2s, 2. Move across, 2p. Element's not there, so it means your 2 p's, your x, y, and z for the p's, are completely full. So if you can't remember that p's can hold up to 6 electrons, again, use the periodic table as your friend here. So 1, 2, 3, 4, 5, 6. So this is going to be 2p, 6. Drop down, we're at 3s. Element's not there, so 1, 2. Your 3s's are completely full with 2 electrons. Move across, 3p. Not there, so completely full, so 3p, 6. Drop down, 4s. Completely full. Now remember, this right here, this line separates the S and D's. So do not count all of these for the S's. So this means this is 4s2. Now when you get to your D's, you have to remember to subtract 1 from the row number. So we get 3D. And you count if you can't remember how many D holds. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 3D10. Move across. 4P. 1, 2, 3, 4, 5, 6. Drop down. 5S. Our element's not there, so 5S2. Move across. 4D. Now our element is in the 4Ds, so we're going to count 1, 2, 3, 4, 5, 6, 7, 8. So 4D, 8. Now, remember to double check yourself. You can add up all the exponents and it should match your atomic number of this element. And this element should be PD. And the atomic number is 46. And that does equal 46. Okay? Now we're going to go into the orbital diagrams and bring it back to electron configuration. So if you remember with orbital diagrams, that's where we're going to put our arrows. We determine the number of arrows that we're going to put into the diagram based on the atomic number. So if you look at oxygen on the periodic table, its atomic number is 8. So this means we're going to have 8 arrows. So remember, you always start with 1s and fill up as you go. So with 1s, we're going to go up and then down. So that's 2, 3, 4. And then when we get to our p's, remember we're going to go up. So it's 5, 6, 7, 8. Okay, so that's review from the previous video. And again, you count to make sure you have 8 arrows, and therefore you get that. Now, this relates to your electron configuration because it should be exactly the same. So oxygen, if we go back to our periodic table, oxygen is here. So this means we're going to go 1s, 2, because it's not in the 1, so we're going to completely fill it up. Then we drop down to 2, S, because it's right there. Move across, we're still on row 2, so we're going to put, it's 2S, 2, because it's completely full. Move across, we're still on row 2, but now we've hit the P block, so you're going to put 2P, and then our element is there, so you're going to count to the element. So 1, 2, 3, 4. And there you go. So the electron configuration for oxygen is 1s2, 2s2, 2p4. Now, I want you to compare this to the orbital diagram that we just did. 1s has 2 arrows, 2s has 2 arrows, 2p has 4 arrows. It should be exactly the same. Okay? Now, if you get to the very bottom of the periodic table, the electron configuration gets longer and longer and longer. So we're going to fix that with what's called shorthand configuration. So we're going to do sulfur. We're going to find the longhand configuration for sulfur first. So go back to your periodic table. Sulfur is here. Okay, so that means we need to go all the way to the S here. So we're going to take it a little bit slow here and make sure everybody's got this. So S, remember you start at the top always. So 1S. Sulfur's not there, so that means all the electrons that are able to go into 1s are going to go. So 1s, 2, drop down. We're now in the 2s's. So 2s, all the electrons fit in it. So 2s, 2. Move across. We're still in row 2, but now we've hit the P block. So 2p. Our element's not there because remember we're going to sulfur that's here. So that means 1, 2, 3, 4, 5, 6. Drop down, 3s. Our element's not in there, so it's going to be 3s, 2, because the s's are completely filled. Move across, we're still on row 3, but now we've hit the P block. So 3p. And sulfur is there, so we're going to count to it. 1, 2, 3, 4. So that's the electron configuration for sulfur. Now, like I was just saying, it's going to get longer and longer as we go because you're going to keep on adding orbitals. So they've come up with this shorthand configuration. So to do shorthand configuration, you're simply going to follow the following steps. You're going to find your element, which again, remember is there, right here. You're going to go up 1 row, so we're going to go from sulfur to oxygen, and go all the way to the right. So up 1 row, all the way to the right. Whatever element is there, you're going to put into brackets. So we're going to put Ne in brackets. Now what this does is it's going to take place, the configuration for all the way from 1s to that element. So it's pretty much covered. So again, you go up one row all the way to the right. Whatever element that is, you're going to put into brackets. Now that element should always come from this column here, the last column of the periodic table. It shouldn't come from anywhere else. That's why you go up and all the way to the right. Now, you're not done. It's not that easy. So you go up all the way to the right. That takes place of the configuration up to that point. So then your thing you have to do last is finish the configuration from that point. So you go back to the beginning row that your element is on. So in this case, we're going to go back to row 3 and finish that configuration. So that means it's simply going to be 3s2, 3p4, and that is it. Okay, so up one row all the way to the right, finish the configuration that your element is on, and that's how you get that. Now, this shows you several different things actually. So if you can tell, the Ne is replacing that part of the configuration. These are called your core electrons because they're on the inside. Then this part, the part that's left over, these are the electrons that are in the outermost energy level. So these are called your valence electrons. So you can simply figure out the number of valence electrons by looking at the longhand configuration or the shorthand configuration. So all you do is you look at the greatest energy level and add up these exponents. So you can tell sulfur has 6 valence electrons simply by doing 2 plus 4, because you look at that greater energy level. We're going to do more in class, so if you're a little bit still confused, hopefully by the end of class you'll be okay.